The race to build artificial intelligence is just getting faster and faster. But as the pace picks up, it forces this huge question on all of us. Is this some kind of winner-take-all fight, or is there a smarter, more stable way forward? Today, we're diving deep into that very choice, that critical tipping point between competition and cooperation in AI. And this feeling, which TED's Chris Anderson captured perfectly in a recent chat with OpenAI's Sam Altman, really gets to the heart of the whole thing. It's this pressure cooker environment, right? The fear that you're going to fall behind makes everybody move faster, maybe way faster than they should. This competitive feeling has become this invisible hand, shaping the entire future of AI. So that brings us to our big question. Is all this frantic competition really the best way to make progress? Or is it actually what you might call a thermodynamic dead end? An incredibly inefficient system that's just doomed to burn itself out. Kind of like an engine that wastes most of its energy on friction and heat instead of actually going anywhere. We're going to analyze this not with opinions, but through the hard lens of mathematics. Okay, let's start by really breaking down the dilemma that every major player in the AI space is facing right now. The decisions being made today could seriously lock us into one path for decades. The stakes, they couldn't be higher. And here it is, right from Sam Altman himself. You can hear the conflict in his own words. On one hand, he's saying, hey, let's be cautious. But on the other, there's this really powerful fear of being run by somebody else. That one sentence just shows you the immense pressure to keep racing ahead, even when you know there are massive risks. So how on earth do we make sense of a dynamic this complicated? Well, it turns out there's a really powerful framework from a field you wouldn't expect. Ecology, that gives us a way to go from these vague feelings to a precise data-driven diagnosis. It's called the Modified Energetic Lotka-Volterra framework, or MELV for short. It's basically a mathematical model that predicts how systems change based on what's most energy efficient. And what it argues is that cooperation isn't just some nice moral choice. It's often the most logical, most stable, and most efficient outcome for any system. This visual here explains the core idea perfectly. The MELV framework maps every interaction on this spectrum, from all-out costly conflict on one side to deep, stable cooperation on the other. And that critical line in the sand is right in the middle, I equals 1.0, where a system falls on this map basically decides its future. So that letter I stands for the I factor. Just think of it as a single number that boils the whole complex dynamic down by measuring how much energy it costs for players to interact. If the I factor is high, interactions are expensive and competitive. If it's low, they're beneficial and cooperative. It tells you, flat out, whether it's smarter to fight or to team up. So can we actually use this framework to diagnose what's happening in AI development right now? Let's find out. We're going to apply it directly to Sam Altman's words, basically treating what he says as data points reflecting the mindset inside OpenAI. And what's so fascinating is that Altman's interview is sending a ton of mixed signals. You can see on one side, you've got all this competitive language, that fear of being run by others, which points to an I factor greater than 1. But then on the other side, you hear these cooperative signals, talk about communication, shared safety concerns, which suggest an I factor less than 1. The system is literally being pulled in 2 directions at once. This table just maps those signals directly onto the framework's language. That competitive talk, it puts the dynamic firmly in what's called the competition basin. But the cooperative talk, that points toward the cooperation basin. It shows a system that's totally in tension, caught between 2 very different futures. So if you weigh all the evidence from the interview where that competitive fear seems to consistently win out over the desire to collaborate, we can estimate a current I factor for the whole AI ecosystem at around 1.5. Now, this isn't some hyper-precise calculation, but it's an assessment that puts the dynamics squarely in the middle of the competitive zone, a state where interactions are costly and really inefficient. So what does that number 1.5 really mean? Well, it's a diagnosis. It tells us the system is burning a huge amount of energy on conflict instead of on productive work. It's like that bad engine again, wasting most of its fuel as heat and noise. And according to the math, a state like this is inherently unstable. It simply can't last. All right, so if the current path is unstable, what's the fix? Let's take a look at what the framework suggests for how we can consciously, deliberately move from costly competition to stable cooperation. And the answer lies right here in what's called the interaction evolution engine. The big takeaway from this is that we don't have to just sit around and wait for a slow, painful evolution to find a better way. That feedback loop you see shows that we can consciously design systems that encourage cooperation, speeding up the shift to a much more stable place. This is humanity's ace in the hole, and the framework even has a name for it: the Consciousness Accelerator, or Epsilon. While nature kind of plods along with an epsilon of about 1, our ability to think ahead and design systems gives us an epsilon of 8 to 15. What that means is we have the power to shortcut evolution. We can shift from competition to cooperation in years or decades, not the thousands of years it takes in nature. It's our species' design advantage. So what does that conscious design actually look like for AI? Well, this blueprint suggests 4 really concrete steps, and each one is specifically designed to lower the cost of interacting, which in turn lowers the I factor. If you share safety research, you reduce wasted effort. If you create international standards, you reduce friction. External audits build trust. And if you distribute the benefits, everyone has a reason to want a stable, cooperative outcome. This quote right here gets to the absolute core of the whole thing. This isn't about asking giant companies to just be nice. It's about redesigning the playing field so that cooperation becomes the most logical, the most efficient, and honestly, the most profitable strategy. It's about making cooperation mathematically rational. And if you're thinking, well, this sounds great, but is it realistic? Just look at the framework's own data. Across thousands of simulations, a stunning 78% of all stable systems naturally evolve to be cooperative. Competition, the state we're in now, only accounted for a tiny unstable 5.8%. Cooperation isn't the exception. The math shows it's the default state for any system that's built to last. And that leaves us with this final, really urgent choice. The math is clear. Cooperation is the only path to long-term stability. And we have this unique ability to consciously design that future right now. The question isn't if the AI world will eventually move towards cooperation, it's how it'll get there. Will we use our intelligence to design it, or will we wait to be forced into it by a wasteful and maybe even dangerous collapse of the system we have today?